in syllabus, where does we study this topic? But you don't have to tell me. Already, I have given a detailed note and I have given a PPT and I have taken the class, everything. But now I thought I'll just have it's a very important process because I have seen this in the question papers of our, not the same syllabus, different syllabus. So I thought I will just have an overall look. Since we are just brushing up of the topics, that's why. Okay, so gear production process. That's what we want today. We have to deal with. So could anyone, Rahul, could you just tell me? We were discussing about this gear production process in which module?
So third module.
Are you sure it was in the third module?
Yes, sir.
Yes, we were discussing about the gear production process in the third module, like gear cutting methods, gear hopping, bevel gear cutting, all that. Okay, so we are discussing in the third module. So now I will start with the gear production process. Then we will discussing about the nomenclature of the gear tooth. Then we will be discussing about the method of making gears, and that's what the main three topics which comes under the gear production. So in the case of gear production, okay, in the case of gear production, what happens is a gear, okay, in the case of gear production process, a gear, what do you mean gear? By the meantime, just have an overview of this figure. This you might have already drawn in your notebook. I hope so because I have explained this in the class and I have told you to draw the figure in your notebook. So please take it up. So please go to the third module and can see this figure in your notebook. So my explanation will be helpful for you. Okay, please find it out. So now we will start with gear production process. So a gear, what do you mean by gear? A gear is an important machine element which is used for the transmitting of power or motion or both from one shaft to other. The best example what we can say in the case of gear production process where gears be used, can anyone could you just tell me? I will ask to only 7 members. What happened to the rest of the people? Okay, I'll ask to Pratish Premraj. Could you just tell me where do we find the best or the appropriate application of gears? Where do we find the best or the appropriate application of gears?
Engines.
Yeah, that's what. Mainly in the case of engines. Okay. Mainly in the case of engines. That's what we say. So in the case of gear production process, what happens is a gear is an important machine. Okay. A gear is an important machine element which is used for the transmission of power or motion or both from one shaft to the other. Both. But in the case of gear production, it is an important machine element which is used for the transmission of power or motion or both from one shaft to the other. It is normally a round blank carrying projections or teeth along its periphery. So what happens is it is normally a very round blank. It may carry projections or teeth. That is the teeth. The teeth may be respective of the angles or according to the type of gear, purpose of the gear, working of the gear, or the gear where it's employed. All that functionality will be considered while designing a gear. Okay. So what happens is in the case normally a round blank carrying projections or teeth. Okay. In the case normally a round blank carrying projections or teeth along its periphery, which enables a positive drive. It always enables a positive drive. Then in this case, the gears are vastly employed to form mechanism for transmissions. In this case, what happens is gears are vastly employed. In this case, gears are vastly employed to form mechanisms of transmission of power from one part to the other in a machine and to affect change in speed or torque or both of one part with respect to the other. That's what happens. So in this case, a gear, okay, a gear is an important machine element. In this case, a gear is an important machine element. Okay, in this case, what happens is a gear is an important machine element which is used for the transmission of power or motion. So in this case, a gear is an important machine element which is used for the transmission of power or motion or both from one shaft to the other or from both from one shaft to the other. Then it is normally a round blank. It is normally a round blank. Okay, it is always normally a round blank carrying projections or teeth along its periphery, which enables a positive drive. It always enables a positive drive. Then in this case, the gears are vastly employed to form mechanism for transmission of power. In this case, what happens is gears are vastly employed. Okay, in this case, gears are vastly employed to form mechanisms for transmission of power from one part to the another in a machine and to affect the change in speed or torque, or both the one parts happen. So what happens is, here we have a gear which is an important machine. It is mainly used for transmission of power or motion from one shaft to the other. It is always consists of a round blank. It always consists of a round blank. It always consists of a round blank carrying projections of teeth along its periphery. Okay, along its periphery, along its periphery. That's what happens. Then what happens is, which enables also a positive drive. But this case, it is mainly employed for the mechanisms of torque or both of one part with respect to the other. Then many different types of gears are used, and the selection is governed by many factors. So many different types of gears are used. Okay, in this case, many different types of gears. Okay, in this case, many different types of gears are used. Many different types of gears are used, and the selection is always governed in many factors, as I told, relative motion like two shafts, load, power, etc. So this is what happens. Now we will start with the nomenclature of a gear tooth. In the gear production, it plays a very important role, because while we are doing a gear production or various methods, we should first know what are the principal parts of a gear tooth and how does we deal with the nomenclature of a gear tooth. That's what are the principal parts of the gear tooth, and also how does we does it with that. So what happens over here is, we in the example of nomenclature of tooth, already we have mentioned. Okay, already we have mentioned all this. The principal part of gear tooth, where which have a pitch circle diameter, addendum circle. You see, addendum, dedendum again. Okay, addendum circle, dedendum circle, tool thickness, face width, tool face, tooth flank, clearance, fillet, circular part, diametral pitch, and the module. These are the 14 very important aspects when we are considering or designing a gear with respect to the production process. Okay, with always with respect to the production process when we are maintaining or when we are manufacturing a gear. So we cannot say all the gears are same. According to the teeth dimensions and according to the teeth aspects, the gear will be always having different changes. So in the case of a normal gear tooth, what happens is, the principal part of a gear tooth, first one is the pitch circle diameter. Okay, first one was the pitch. Okay, first one is the pitch circle diameter, that is the capital D. Okay, this is the principles of gear tooth illustrated. First one is the pitch circle diameter, that is capital D, where you can see this in the figure. Okay, where you can see this in the figure. This is the pitch circle diameter. Okay, so this is the pitch circle diameter. The small line is named as, I hope so you're seeing my cursor. The small line is named as the pitch circle diameter. Okay, that's what we name it as, the pitch circle diameter. Okay, this is what you can see, it is a seventh one, pitch circle diameter. You can see that. Okay, then what we say pitch circle diameter, it is always represented as capital D. That is, it is the diameter of the circle. It is always the diameter of the circle which by pure rolling action would transmit the same motion as their actual gear wheels. So in the case of pitch circle diameter, that is capital D, it is the diameter of the circle. Okay, it is the diameter of the circle which by pure rolling action would transmit the same motion as their actual gear wheels. That's what happens in the nomenclature of gear tooth, where the principal parts of the gear tooth are, first one is the pitch cycle diameter, which is represented as capital D. That is what happens. It is the diameter of the circle. Okay, it is always the diameter of the circle which by pure rolling action, it is always by the pure rolling action, would transmit the same motion, would transmit the same motion as their actual gear wheels, would transmit the same motion as their actual gear wheels. Then second one is the addendum circle. Second one is the addendum circle. It is also known as outside diameter. Okay, this addendum circle, it is also known as outside diameter, and it is a circle passing through the crest of the gear teeth. And it is addendum circle, it is also known as outside diameter. It is a circle passing through the crest of the gear teeth. That's what happens in respect to the nomenclature of gear tooth, where the principal parts of a gear tooth are illustrated, where the pitch circle diameter, that's the capital D, which is named as, it is the diameter of the circle which by pure rolling action, it's always the diameter of the circle which by pure rolling action would transmit the same motion as their actual gear wheels. That's what where there is no depreciation of power or there is no lossage of power as the work is getting transmitted to the equally without no load distribution or no load or no what happens is destroy. Like we can say the theoretical application as well as the practical application. That's what we say. Then second one is the addendum circle. Okay, again you can see in the figure. I hope you have written a notebook also. This is the addendum circle. Okay, this one is the addendum circle. Okay, this one's curve. Okay, small curve. That's what we the addendum circle. So what happens is that over there, what happens is like addendum circle. It is also known as the outside diameter, and it is a circle passing through the crest of the gear teeth. So it is also known as basically you can say it is the outside dimension, it is the outer portion, and a circle passing through the crest of the gear teeth. It's always a circle passing through the crest of the gear teeth. That's what happens. Then the third one automatically it will be when we are measuring about addendum circle, we had already mentioned about the addendum. So here comes the addendum. This is the one. Okay, this is the addendum. You see in the topmost portion of the gear tooth. Okay, so this is a single gear tooth representation. Hope so everyone is understanding. This is a representation of there will be so many of the various gear tooths present adjacent to this gear tooth. So in order for the graphical representation, we have just drawn one and we are describing it. So in the case of addendum, it is a radial distance. It is always the radial distance from the pitch circle to the top of the tooth face. That's what happens. In the case of addendum, it is the radial distance. Okay, it is the radial distance from the pitch circle to the top of the tooth face. That's what happens in the case of addendum. Okay, in the case of addendum, it is the radial distance. It's always the radial distance from the pitch circle to the top of the tooth face. That's what happens in the case of addendum. Okay, it is the radial distance from the pitch circle to the top of the tooth face. Fourth one is the dedendum circle or root circle. It is the circle passing through the roots of the gear teeth. It is mainly the circle passing through the roots of the gear teeth. Okay, in the case of dedendum circle or root circle. Okay, in the case of dedendum circle or root circle, it is the circle passing through the roots of the gear teeth. Okay, in the case of dedendum circle or root circle, it is the circle. It is always the circle passing through the roots of the gear teeth. It's always the circle passing through the roots of the gear teeth. That's what happens in the case of dedendum circle. So this is what we name it as dedendum circle. Okay, this one. See, this is the roots. Okay, so it is a circle passing through the basically downwards to the roots of the gear teeth. Then we have a dedendum, the radial distance between the pitch circle to the root circle. Okay, it is mainly the radial distance between the pitch circle. So see, this is the radial distance to the pitch circle to the root circle. That's what we say. It is equal to the addendum plus the clearance. It's always equal to the addendum plus the. So it is always the combination of our addendum and thus plus the clearance of the teeth. That's what happens. So in the case of dedendum, it is a circle passing through the roots of the gear teeth, and in the case of dedendum, the radial distance between the pitch circle to the root circle is equal to dedendum plus the clearance. So it is always mentioning as the dedendum and the addendum plus the clearance. Okay, now it comes to the tool thickness. Okay, now it comes with the tool thickness. Okay, that's the tool thickness. So this thickness is always measured with the help of the pitch circle. Okay, I hope so. You remember what you mean by pitch circle? It's the diameter of the circle, which by pure rolling section would transmit the same motion as the actual gear. That's the purpose of pitch circle. But so we can also name it as a reference line also. That's what we can say. So what happens is in the case of tool thickness, the thickness measured along the pitch circle is always available. Then comes with the face width. Okay, then it always comes with the face width. Face width is the length of the gear in an axial plane. In this case, what happens to the face width? It is always the length of the gear. It is always the length of the gear in an axial plane. That's what happens with the face width. It is always the length of the gear in an axial plane. Then comes the tooth face. Okay, then it mainly comes the tooth face. Tooth face is the mating surface. Okay, the mating surface between the pitch circle and the addendum circle. Okay, the tooth face is the mating surface between the pitch circle and the addendum circle. That's what happens in the case of tooth face. Okay, in the case of tooth face, that's the mating surface between the pitch circle and the addendum circle. Then comes the tooth flank. Okay, then comes the tooth flank, the mating surface between the pitch circle and the root circle. That's becoming the tooth flank. So what happens over here is the first case it is like what is like the pitch circle diameter, the second one was the addendum circle, the pitch circle diameter, it is the transmission relation. Then in the case of addendum circle, it is the outside diameter of circle passing through the gear. Then comes to the addendum, it's a radial distance. Dedendum, it is a circle passing the road to the gears. Then it is a distance between the pitch circle and the root circle dedendum. tool thickness measured with the respect to the pitch circle. Then face width, it is the length of the gear in the axial plane. Okay, so this is what we mean by face width. Okay, face width is mainly this one. Okay, face width is mainly the length of the axial plane. That's what happens with respect to the face width, length of the gear in the axial plane. Then comes the tooth face. The tooth face is the mating surface between the pitch circle and the addendum circle. In the case of tooth face, it is always the mating surface. In the case of tooth face, it is the mating surface between the pitch circle and the addendum circle. It is always the mating surface between the pitch circle and the addendum circle. In the tooth face, it is always the mating surface between the pitch circle and the addendum circle. Then comes the tooth flank. Okay. Then comes the tooth flank. Okay. Then comes with the tooth flank, the mating surface. Okay. Tooth flank. What happens is the mating surface between the pitch circle and the root circle. That's what happens with the tooth flank, the mating surface between the pitch circle and the root circle. Okay. So that's what happens in tooth flank. Then comes the clearance. Then comes to the clearance. Clearance is, it is a small distance. It's always a small distance that is provided. It's always a small distance that is provided so that the top of the meshing teeth will not touch the bottom of the other gear. That's what happens in the case of clearance. It is a small distance. Okay, it is always a small distance that is provided so that it's always a small distance. Okay, it's a small distance that is provided so that the top of the meshing teeth will not touch the bottom of the other gear. Okay, that's what the top of the meshing teeth will not touch the bottom of the other gear. That's what happens with respect to the clearance. Okay, what happens is it is a small distance that is provided where the top of the meshing teeth will not touch the bottom of the other gear. Then comes to the fillet. Fillet. It is a small radius at the bottom of each tool flank. Okay. In the case of fillet, it is a small radius. It always is a small radius at the bottom of the each tooth flank. So this happens with the fillet. So this is the fillet. Okay, this is the ninth one. You can name it as ninth one. This is the fillet. This one. See, this is the fillet. So this is the, it's a small radius at the bottom of each tooth flank. So this is the small, see this curve, the small radius. That's what we say tooth flank. So it is a small distance that is provided. So at the top of the tooth flank, that's what happens. Okay, the mating surface of the pitch circle. So this is the tooth flank. Then comes the clearance. Okay, then comes the clearance, then comes the fillet, then comes the circular path, where it is a distance between the two consecutive gears of gear measured along the pitch circle. It's always described as it is a distance between the two consecutive teeth of a gear measured along the pitch circle. That's what we say. The circular path is always the distance between the two consecutive teeth of gear measured along the pitch circle, which is equal to, that's what we can say, V is equal to pi d by t. This is circular pitch. D is capital D is pitch circle diameter, etc. Then comes the diametral pitch. Okay. Okay. So circular pitch is represented P C. It is pi d by t, where d is the pitch circle diameter and capital T is the number of teeth. Number of teeth employed in the gears. Okay. Number of teeth employed in the gears. Then the 13th one is the diameter pitch. Okay. Diametral pitch, where it is a ratio of the number of teeth. Okay. It is the ratio of the number of teeth and the diameter of pitch circle. In the case of diametral pitch, it is the ratio of the number of teeth. Okay, it's always the ratio of the number of teeth and the diameter of the pitch circle. That's what we say. In the case of diametral pitch, it is a ratio. It is always the ratio of the number of diameter of the teeth and the diameter of the pitch circle. That's what happens. So the PD is equal to T by D is the diametral pitch. Then comes the module one, fourth one is the module. It is the ratio of the pitch circle and the number of teeth. Okay, this is what. That is the ratio of the pitch circle and the number of teeth. That's what is the module. So these are the main aspects of, okay, these are the main aspects of what? Can anyone of you say these are the main aspects of, I'll ask Amit, could you just tell me what we were discussing this 15, 14 parts? What are the main aspects which come, how does it, on which subtitle comes under? Amit. Yes, Amit, you raised your hand. Just tell me, okay, this 14 descriptions was described in with respect to the Amit. Yes, tell me, Amit. Why are you not opening the mic? Okay, then leave. Agilem, Amit, this you are repeating several times. Okay, Amit, Agilem.
Sir,
We are discussing all this. Where does it come? What are topics? What are topics?
method of making gears. So,
I, we were
so
discussing about all these 14 things. So, where does it comes under? What we are discussing? Addendum, pitch, circle, module, fillet, phase tooth, everything we have discussed now, right? So, it comes under which topic I'm asking?
machine tool. Day. Gears. Correct.
Gears and wow, yeah, what related to gears? Karthik, could you just tell me what related to gears?
So teeth അല്ലേ?
With the nomenclature of gear tooth. Okay, it is the nomenclature of gear tooth. Now, okay, fine. Now we'll start with the methods of making gears. Okay, now we will start with the methods of making gears. Okay, so what happens is here, what happens is gear making. Gear making is a highly specialized job. Okay, the methods of making gear is the case of gear making. It is a highly specialized job. Then gears may be produced by a number of different processes. Okay, so in the case of method of making gears, gear making is a highly specialized job. Okay, in the case of method of making gears, it is a highly specialized job. Okay, in the case of method of making gears, it is always a highly specialized job where the gears may be produced by a number of different processes. According to the purpose, the gears may be produced by a number of different processes. The following are the methods commonly used for making gears. Okay, the commonly are the methods of normally making gears. Okay, that's what happens. So what happens is first one is casting. Okay, this first one is casting. Okay, the first one is casting. Okay, casting, it comes with sand casting, die casting, and investment casting. Sand casting, die casting, and investment casting. That's what happens. The case of casting, it is the sand casting, die casting, and an investment casting. Okay, that's what. Then what happens? Then what happens? Sand casting, die casting, and investment casting. That's the first one. Then the second one is the form cutter method by form cutter milling machine, by form cutter shaper, and template process cutter. So we will start with the first with the casting of gears. Okay, casting of gears, then the form cutter process. So the form casting for sand casting, die casting, investment casting. This we have already discussed with respect to the casting process, the manufacturing process also. So now we start with the casting. Okay, now we start with the casting of gears. So this is what it's mainly mold. Okay, so the gears are casted in sand molds, permanent molds, shell molds, plastic mold dies, and lost wax molds, etc. So according to the purpose, requirement, functionality, and everything, we will be the casting of gears. So the gears are casted in mainly in sand molds. Okay, what happens casting of gears? The gears are casted in sand molds, then permanent molds, shell molds, plastic molds, dies, and lost wax molds, etc. So what happens is mainly in the case of casting of gears, the gears are casted in sand molds. Okay, that means that mainly in the case of casting of gears, the gears are casted in sand molds, then permanent molds also. In permanent molds, then permanent. Okay, it is always permanent molds, then shell molds, plastic dye mold dies, and molds. So the characteristics of gears produced by casting are same as those of other products. Maybe these process. That's what happens. So always the characteristics of gears which are produced by casting are same as those of other products. Maybe process. So sand casting is particularly used for making heavy gears of cast iron and steel. So why do we use cast iron and steel of gear making? What is the main purpose? I already told. Why do we use the cast iron as the major component for production of gears? I'll ask you, Mohammed Asaf, could you just tell me why do we use cast iron? What property of cast iron and steel, or what property of cast iron which makes it the etc. suitable for raw material for making of gears?
High strength.
Okay, then what else? Not only high strength, the other important factor. No, no. Okay, high strength is a one factor. Then other factors what?
Good bearing power.
Ah, okay. Then good wearing resistance. Then
Ease of
ease of.
producing complicated shapes.
Okay. Then it is used as substitute for some other purpose. So
Less
automatically when
expensive.
some less expensive, no, it's not right. It's quite expensive only. But we have, as we see the gears in automobiles, other important factors are, it's a clue.
Corrosion resistance.
Yeah, it's told where is that's already described. Weight. Okay. Regarding the weight of the components. Okay. As it's an automobile, the weight also plays a very important factor, right? Right, Asaf?
Yes, sir.
So the weight is also plays a very important factor. So what happens is the characteristics of gear produced by casting are some of those of the other products which are made by these process. Then sand casting is particularly used for making heavy gears of cast iron and steel. So sand casting is mainly used for making heavy gears of cast iron and steel. Then gears made by this process have poor accuracy. Okay, in this case, what happens is the gears. Okay, the gears made by this process have poor accuracy. These are mostly used for slow speed drive and are also not very efficient in power transmission. So that's what happens. What happens is these are mostly used for slow speed drive. Okay, these are mostly used for slow speed drive and are also not very efficient in power transmission. That's what happens. So what happens is like over here the gear casting of gears where the gear cast are in sand molds, the permanent molds, shell molds, plastic molds, dies and lost wax molds. So the characteristics of gears produced by casting, okay, the characteristics of gear produced by casting are same as that of the other products, made by these processes. Then, sand casting is particularly used for making heavy gears of cast iron and steel. So, what happens? Sand casting is particularly used for making heavy gears of cast iron and steel. Then, gears made by this process. Okay, gears made by this process have poor accuracy. Okay, gears made by this process have poor accuracy. These are mostly used for slow speed drive. Okay, so mainly the gears with this process have poor accuracy, but these are mostly used for slow speed drive and are also not very efficient in power transmission. So die casting gears are used where light loads to be transmitted. These are made from low melting temperatures such as aluminum, zinc, etc. The process of casting is normally okay. The process of casting is normally used where economy is the main criteria. Okay, where economy is the main criteria. That's what happens. So what happens over here is the where the economy is the main criteria. So the process of cast is normally used when economy is the main criteria, and the sand cast gears may be machined for a good finish. And the sand cast gears may be machined for a good finish. That's what happens. And the sand cast gears always machined for a good finish. That's what happens. Then the growing importance of shell molding may introduce another important method of producing nearly finished gears. Okay, that's what happens. The growing importance of shell molding may introduce. Okay, the growing importance of a shell molding may introduce another important method of producing nearly finished gears. Then, die casting gears have sufficient accuracy and have sufficient surface finish. Okay, mainly the die casting gears have sufficient accuracy and high surface finish. Then, plastic molding is also used to produce the desired teeth of plastic materials for very light work. Okay, for very light work. That's what happened. In the case of die casting gears, have sufficient accuracy and high surface finish. Then plastic molding is also used for producing desired teeth of plastic materials for very light work. That's what happens. Then second one is mainly related to the formed cutter process. Second one is mainly related to the formed cutter process. Okay, formed cutter process. So this method of production. Okay, so this method of production of gears uses a single point cutting tool. In the case of formed cutter process, I hope so. Yesterday we have discussed the same figure. Could anyone of you tell me? Yesterday we have in the case of gear forming, we have discussed the same figure which was related. So this is the main thing where we'll cut the gear blank into required number of teeth according to the purpose, dimensions, everything. So what happens over here is we have a formed cutter process. In this case, what happens is we have a formed cutter process where the method of production of gears, it's mainly the method of production of gears, which uses a single point cutting tool. It always uses a single point cutting tool or a milling cutter. Okay, it always uses a single point cutting tool or a milling cutter having the same form on a cutting edge. Okay, the case of formed cutter process, it is mainly related to the methods of production of gears using a single point cutting tool or a milling cutter. It is mainly using a single point cutting tool or a milling cutter having the same having the same form and cutting edge. Okay, having the same form and cutting edge as the space between the teeth being cut. Okay, as the space between the teeth being cut. Then the form cutting method is only used where a very small number of gears are to be manufactured, where too much of accuracy is not demanded. That's what happens with the help of formed cutter process. So in the case of formed cutter process, what happens is the method of production of gears, it's mainly the method of production of gears uses a single point cutting tool. It's mainly the method of production of gears which uses a single point cutting tool or a milling cutter. It's always a miller or a milling cutter having the same form on cutting edge, having the same form on cutting edge as the space between the teeth being cut. And the form cutting method only used where a very small number of gears are to manufacture. Okay, so form cutting method only used where a very small numbers of gears are to manufacture and where too much accuracy is not demanded. And in this case, there is not too much of accuracy required. That's what happens. So this method mainly uses simple and cheap tools in conventional machines. Okay, this method uses mainly simple and cheap tools in conventional machines, and the setup required is also simple. And to an extent, the setup required is also simple. The formed method possesses certain inherent disadvantages. Okay, the formed method possesses certain inherent disadvantages. So they are describable. First one is the gear tooth accuracy is very poor. First one is the gear tooth accuracy. It is always very poor. Second one is the production capacity. The production capacity is always very low due to the wastage in measuring time for indexing, withdrawing, and advancing the cutter or the work after measuring each tooth space. That's what happens in the case of formed cutter process, where it uses a single point cutting tool for a milling cutter having the same cutting edge and the space between the time being cut. The form cutting method is only used for a very small number of gears. Okay, it is always used for a only for a very small number of gears which are to be manufactured, which are to be manufactured, and where too much accuracy is demanded. In that case, what happens where too much accuracy is not demanded, then the method uses almost simple and cheap tools in conventional measures. Okay, so this method mainly uses simple and cheap tools in conventional methods, and the setup required is also simple. So the formed method process contains certain inherent disadvantages, like the gear tooth accuracy is comparatively poor, then the production capacity is very low. Automatically the production capacity is very low due to the production capacity is very low due to wastage in measuring time for indexing. Due to wastage in measuring time for indexing. Okay, due to wastage in measuring time for indexing, withdrawing, and advancing the cutter of work after machining each tooth space. So that's what happens. So where these are described below, first one is the gear tooth accuracy is comparatively poor. Then the production capacity is always very low due to wastage of machining the time for indexing, withdrawing, and advancing the cutter of work after machining each tooth space. So in this case, what happens is last one is the form cutter process. Okay, this one is the form cutter process where spur gears are easily produced on plain and universal milling machine by using a form cutter, disc cutter, and mill cutter. So this is what happens in the case of a form cutter, and this is how the gear has been formed, and this is the disc cutter and the arbor. Okay, so this is where the gears form. So what happens is over here is the spur gears are easily produced on the plain and universal milling machine by using a cutter. So in this process of gear making, okay, mainly in this, it's always the in this process. Okay, so in this process, what happens is in this process of gear making, the gear blank is held between the centers. In this process of gear making, the gear blank is always held between the centers. Okay, in this process of gear making, the gear blank, it is always held between the centers, usually on a mandrel and connected to the dividing heads. Okay, usually on a mandrel. Okay, it is mainly usually on a mandrel and connected to the dividing heads by means of a dog. I hope so you remember what you mean by dog, arbor, mandrel, everything. Okay, I hope so you remember what you mean by dog, arbor, and mandrel. Okay, that's what. So what happens is like in this process of gear making, the gear blank is held between the centers, usually a mandrel arc and connected to the very head by dog. So the cutter is mounted on the arbor as shown in the figure. You can see the figure where the cutter is always mounted on the arbor. So yesterday I asked you what's the purpose of an arbor. Okay, so the cutter is mounted on arbor on figure with the axis of rotation. So the index it is properly adjusted so that its center line is truly radial with regard to the blank. In order for the cutting operation, there should be minimum amount of error. So always we should have a reference line or a center line in order to have the in order to scale the product. Okay, in order to properly scale the product, and at the same time, what happens? We have to always check whether the dimensions accuracy and all the rates are proper. If the dimension accuracy is not proper, automatically the whole gear becomes not disabled or becomes not proper. That's what happens. So in this process of gear making, the gear blank is held between the centers, usually on a mandrel and connected to the dividing head by means of a dog. The cutter is mounted on the arbor with its axis at right angle, so to the work. It is properly adjusted. Okay, it is properly is properly what happens is it is properly adjusted so that okay it is properly adjusted so that its center line is truly radial. Okay, it is properly adjusted so that its center line is truly radial with regard to the blank. Okay, it is properly adjusted that its center line is truly radial with regard to the blank. Then the indexing movements, okay, the indexing movements are determined and the sector arms and the crank pin is adjusted accordingly. So the indexing movements are determined and the sector arms and the crank pin is adjusted accordingly. So the table is brought to the starting position and the knee raised to adjust the required depth of teeth. That's what happens. So what happens in this process of gear making? Automatically, what happens? The gear blank is held between the centers, usually on the mandrel and connected to the dividing head by means of a dog, and the cutter is mounted in arbor with an axis. It is properly adjusted so that its center line is truly radial with regard to the blank. Mainly the indexing movements are determined by the sector arms of time. The table is brought starting position in a single pass. The tooth is finished and table is returned to starting position. So blank is then indexed on next tooth to be cut and operation to go until the required divisions are cut on the periphery of the blank. This is what happens in the case of a foam cutter operation. Okay, this is what happens mainly in the case of a foam cutter operation. Okay, we'll use the form cutter operation. Then the last one we have what and template form cutter and process. Okay, form cutter and process. So in this process, the gears are always made in a vertical milling machine using an end mill cutter. That's what. In this case, the gears are always made using a vertical milling machine using an end mill cutter. They work in the same way as the disc cutters, except their axis of rotation is vertical. In this case, their axis of rotation is vertical. Okay, in this case, what happens is the axis of rotation is always vertical. Okay, and this process is used for cutting teeth of coarse pitch gears for finishing of teeth of cast. In this process, per helical and herringbone gears are produced. That's what happens over here. Okay. Then the case of template gear cutting process. Okay, in the case of template gear cutting process, it is mainly regarding the gear plate. Here the gear plate is held stationary during the process and is removed only when indexed. In this case, what happens is the gear blank is held stationary during the process and is moved only when indexed. This method of cutting produces an accurately formed tooth of having the proper taper. Then machines of this type are used for only for planning the teeth of very large straight level. So in the case of gear blanks, it's held stationary, and during this process, it is moved only when indexed. As per the requirement, only indexed it will be moved. So here to stationary, we have to give an external pressure. So this method of cutting process can accurately form a tooth having proper taper. So we can have proper taper and proper angles can be measured, and we can change the teeth number, everything. So it's the change the teeth number, dimensions, everything. Okay, so the machines of these types of are used only for planing teeth of very large straight bevel gears. So this is what happens in the case for method of production of gears. So I'll just stop the class. Okay, the time is up. Okay.